Okay, let's start. Last class we have studied SNS. Today we are going to see another messaging service known as SQS, Simple Queuing Service, right? SQS. Amazon Amazon SQS is a web service that gives you access to a message queue that can be used to store messages while waiting for a computer to process them. Right? Say, you see here, say this side, one side producer is there, other side consumer is there. Right? Say, once the producer send the message, is in the queue. The messages are in the queue. Say, when the consumer is free, only get the particular message. Right? Still, these messages are in the queue. Right? Say, one side, one application is sending the message. The messages are in queue. If the particular application is free only to access the particular messages, right? So that is known as simple queuing service, right? SQS, right? Amazon SQS is a distributed queue system that enables web service application to quickly and reliably queue of messages that one component in the application messages that one component in the application generate to consume by another component. A queue is a temporary repository for messages that are waiting process, right? So it's a temporary repository. All the messages are in the queue. Okay. Using Amazon SQS, you can decouple the components of an application so they run independently, easing message management between components. Right. Say, let's see, let me open Amazon. SQS, Simple Queue Service. So this is the Amazon SQS, right? Say one side one side producer, other side consumer. This is the producers, other side consumers. Messages are in queue, right? Say if you want to create the queue, just create the queue, right? Right. Right? You can create the message queue. Here we are going to simulate the environment, right? Let's see how to simulate the SQS, right? Right. Any component of distributed application can store messages in the queue. Messages can contain up to 256 KB of text of any format. So the message size would be 256 KB, right? Say when you create the messages, say just say just let's see, just put a name. Anyway, we are going to discuss these things. My queue or something. Say when you say create queue, say they're saying the name already exists. They say let me put QA or something, right? Say create queue. Here say the message size. Here you are going to define the message size. So the message size should be 256 KB of text in any format. Right? The queue acts as buffer between the component producing and saving data, and the component receiving the data for processing. Right? Say this means the queue resolve issues that arise if producer is producing work faster than the consumer can process it, or if the producer or consumer are only intermediately connect to the network. Right? Actually, when the here you see the number of producers are high one side, but the consumers are low, right? So if the producer fastly sending the messages, sometimes the consumer can't process the message. That's what this messages sign queue, right? That's what this messages sign queue, right? Right. Say let's go to this one, the create queue. Right. There are two type of queue. One is standard queue, other one is FIFO queue. Same thing we discuss in SNS as well, right? You see here, there are two type of queue. One is standard queue, other one is FIFO queue, right? Say if it is wait, I think this is not visible here. The queue types. This is the queue types here, guys. One is standard, other one is FIFO. This one, say the standard mean at least one delivery message ordering is in preserved. Preserved. At least one delivery best effort order. Right. So this one, let's see about FIFO. First in, first out delivery. Right. So here is like this. Say this is the standard queue. Here the messages are like this. Say this is one message, this is another message. Maybe this is the last message. So this is the first message we sent. This is the third message. So this is the second message. Here, there's no order, guys. Right? Maybe this fifth message, the last message might deliver first. First message might deliver the second. Right? Say one side producer is there, other side consumer is there. This is the producer, guys. Producer, this is consumer, right? Say producer producing the messages. The message might not be in order, right? Sometimes message might be duplicate, right? Right? The consumer might get messages 2 times, right? So that is the standard queue, right? This is the standard queue, right? So there are 2 queue types. One is standard queue, other one is FIFO. So at least one delivery, best effort order, right? Say FIFO queue, first in, first out deliver. Exactly one processing. Say the FIFO queue is like this. Let me draw the FIFO queue. This is the FIFO queue. Producer, and this is the producer, this is the consumer. Here, the first in, first out, the messages are like this. Messages are order. So this one is the first message. This one is second message. This one is third message. This one is fourth message. This one is fifth message. First in, first out basis, right? Right. It's in the queue. When this consumer is free, he is going to read the message. Say he is polling. So this guy is polling the messages. This process known as polling. Polling, right? Polling the messages. Whenever he free, he get the message. So it's like this. Say I am polling you, right? Say if you are busy, you won't answer the phone. I can't do anything, right? If you are free, you may answer the call, right? Something like that, right? Polling, right? Say here the consumers are polling and get the messages, right? Right, right. So there are 2 queue types here. Standard, other one is FIFO, right? Say let me choose say standard and I put a name here. Just say my say AWS queue or something. Here we are creating the queues, right? Right. Configuration, visibility timeout. Let's see what is visibility timeout, right? Now you know the rough idea about the queues and all, right? Right. So let's see what is visibility timeout. The visibility timeout is the amount of time that the message is invisible in the SQS queue after the reader pick up that message. Now see, let's see what is visibility timeout, right? There's option here, visibility timeout. By default is 30 seconds, right? We can go up to 2 hours, right? Right. Now see, there's a timer is there. There's a timer is there. The timer starts here and timer is running, right? Let's see, we have set the time 10 seconds, right? 10 seconds. Right. He polling the particular queue and get the message. Get the message. If this consumer not process the message within 10 seconds, right? 10 seconds. Then the message again reappear. Again, the particular message reappear. Right? Then another consumer able to read the message. Right? Or the same consumer able to read the message. This is known as visibility timeout. The visible timeout period, right? Message is visible only these seconds. Say, let's see this guy is getting the message, but particular within 10 seconds, he won't process the message, right? He is processing by default. Any reason this processing failed. Then the particular message again reappear, then the timer started again, right? Then another consumer may read the message, or the same consumer again read the message again, and he try to process the message again. That is known as visibility timeout, right? Say here visibility timeout, let's put 10, right? Other one, delivery delay. We can set up to 15 minutes maximum delivery delay. The delivery delay means, say, here you are sending the messages. This side you are sending the messages. Right? You know, these consumers are busy. Say, let's see, there are, say, okay. If the consumers are busy, then you can configure the delivery delay time. That means you just send the message after 2 seconds. After 2 seconds, the messages are here. After 2 seconds, delivery delay. The reason is, you know, these consumers are a bit busy, right? They busy with some other work, so you just delay the message, right? Say, if you set 2 seconds, once you send the message in the queue after 2 seconds, right? That is the meaning of delivery delay. Right? These are applications. This one is one application. This one is another application. Say, delivery delay. Let me put 2 seconds. Right. The maximum message size. This is the 256. You can configure. There should be between 1 KB and 256 KB. Okay, you can't go beyond this amount. Maximum message size. Say this is the maximum message type size, 256 KB in any text format, right? Right. Say the next one. The provided job is processed before the visibility timeout expires. The message will. Sorry, give me 1 second, guys. Okay. Sorry for the internet. All right. Okay. All right. If the job is not processed within that time, the message will become visible again, and another reader will process it. This could result in the same message being delivered twice, right? Sometimes same message might deliver twice, right? delivery visibility timeout 30 seconds. Increase if your task takes greater than 30 seconds, maximum 12 hours. Okay. Right. Now see here. So we have the configured visibility timeout, delivery delay. So next one, message retention period. Right? Issued between 1 minute and 14 days. That means the particular message in the queue, right? The particular message in the queue for 2 days, right? The lifetime of the message, 2 days, right? So that is known as retention period, right? Right. The next one, receive message wait time, right? So receive message wait time. So that means, say by default is 0. Okay. A 0 means short polling. Say if we set the timer here, say 20 seconds, this is known as long polling, right? So retrieve message wait time means, say this guy is sending the messages. So messages are here, all right? So he come here and say, just see any messages are there. He get the messages. If there's no messages, he wait 20 seconds. 20 seconds. On the particular period of time, if there's any messages, then he retrieve the message. He get the message and process, right? If he said 0, so he come here and see if there's any messages, then he process. Say if there's no messages, then he quickly disconnect. He assume there's no messages. It is this one is known as short polling. This one is known as long polling. Okay. He come here and wait 20 seconds and see if there's any messages, then he process. If he said 0, he come here and see if there's any messages, then he process. If not, he quickly disconnect. This is known as short polling. This is known as long polling, right? Right. He come and wait. Okay. He come and wait. The consumer come and wait. Okay. Right. So that is known as short polling and long polling. Say short polling, return immediately even if no messages are in the queue. Right. Sometimes if there's no messages, say let me get new one. Now let's see what is short polling, right? He just come and wait here. Sorry, he just come and see if there's any messages, then he process. If not, he quickly terminate the connection. If it is long polling, he come wait for some time, right? Wait for some time, say for example 20 seconds, and see if there's any messages, then he process. If not, he is going to disconnect, right? He just come and wait, right? Right. right? That is known as long polling, right? Say while the regular short polling returns immediately, right? Long polling doesn't return respond until the message arrives in the message queue or the long polling timeout. As such, long polling can save your money, right? You just come and wait some time and get the messages. That is known as long polling, right? So this is about the retrieve message wait time, say 2 seconds. So this is about the policies and all, right? Say let me choose only queue owner, only queue on, right? You can configure the policies, right? Say if you want to encrypt the message, you can encrypt the messages, right? You can set the retrieve policy as well, right? Right. Say create queue. Now we have created one queue, right? Say this is the queue, AWS my queue. This is the queue we have created, right? Right. Now let's see send and receive messages. Say let's see, let's send the message. Say message body today big sales or something, right? Say the delivery time would be 2 seconds. Say send message, right? Now the message has been sent, right? Message has been sent, right? See the consumer, producer just send a message, right? So after 2 seconds is in the queue, right? The consumer now is going to polling, right? He is going to polling. He is going to polling and get the message, right? Polling, guys. Polling and get the message, right? Right. Let's see how to poll, right? Say just poll messages. Okay. Say poll messages. Now polling started. See the polling started. Okay. Visibility timeout also started. He got the message. Message has been processed. That means the particular message is received by the consumer, right? Is received. Now consumer is going to read the message. Let's click the message and see whether we got the message. Say today big sales, right? Consumer got the message. Consumer got the message, guys, right? Say done, right? Say polling process completed. It's processed the message, is completed. Now we got the message. The message size is 15 bytes, right? The message sent, right? Right. This is known as SQS. Say once the producer send the messages are in the queue, consumer polling and get the message and read the message, right? Right. This is known as SQS, right? Simple queue service. SQS, simple queue service, right? Especially this for queuing process, right? Is in the messages are in the queue. So when the consumers are free, they do the polling and get the message, right? So this is the queuing service, right? Right. Right. Another message processing service is there that is known as Kinesis, right? There's another message processing service. Say, let me open this one. Kinesis, sorry guys. This is also another processing service, Kinesis, right? Let's see how Kinesis works, right? This is especially for streaming messages. Say streaming, online streaming, especially the game data, stock exchange prices, IoT sensor data, social network data. Say if someone update the status, the message quickly appears in other chat box, right? Stock prices, purchase from online stores, right? Say online delivery, right? The streaming. Streaming, we use this one, Kinesis, especially for streaming services, right? Right. Here also the same concept. One side producer is there, other side consumer is there. Say producer may say one side we are producing some messages, we are streaming some messages. It's online streaming, right? So this message goes to one of the consumer, right? Right. Here the streaming data. The wording is very important, guys. SQS is queue, right? Kinesis is streaming, right? The game data, social network, geo location. Say sometimes you order pizza cut. You can track the delivery person location. Okay. The Kinesis is there. Okay. Right. Kinesis is there. Kinesis is going to track the location. Right. Say streaming data is data that generated continuously by thousands of data sources, which typically send its data record simultaneously and in a small sizes, maybe kilobytes. The sizes would be very small, right? These are the use cases, right? Say this is the delivery person application. This is your application. Say this one is producer, this one is the consumer. You track down the delivery person location, where he is located, right? So behind this one, Kinesis is there, right? Online streaming, right? Say especially stock exchange prices. Say Kinesis. Kinesis is a real-time, fully managed and scalable platform for streaming data on AWS. Two main functions in Kinesis: ingesting and processing real-time data, deploying custom real-time application for specific requirement, right? Say here also we have two concept, producer, other one is consumer. Say producer produces the stream data. For example, a web server sending log data to Steam in the producer. Other side consumer is there. Consumer get records from Amazon Kinesis data stream and process them. These consumers are known as Amazon Kinesis data stream application. Right? Let's see. Let me go to Kinesis. Say this is the Kinesis service. Right. Here you see the Kinesis data stream is there. Kinesis data firehose is there. Kinesis data analytics is there. Right. Say you see here the three options are here. One is streaming, other one is firehose. Say let's see what is firehose. Say here, say one application is producing the data. This is the application is producing the data. Right? Streaming Kinesis streaming is receiving the data. Okay, Kinesis streaming is receiving the data. Say Kinesis data stream. This is the Kinesis data stream. Data stream. Right? Data stream. This is the application is producing the data. Kinesis stream is receiving the data. Right? Then there is another component here, firehose. Say firehose, right? Say firehose is getting the data from data stream and deploy to one of the storage. Maybe it deploy to S3 bucket. Sorry, it's deployed to S3 bucket. That is a function of firehose. Okay. This component is receiving the data from data stream, right? Then deploy to S3 bucket. That is a function of firehose. Later, another component is there, analytics. We can analyze the data. We can analyze this data. Okay. We can analyze this data which is inside the S3 bucket. We can take some decision. All right. We can take some decision. Right. To see these three components, data stream, firehose, analysis. You see here, you see all the components. Analysis, data stream, Kinesis data firehose. This one is data analytics, right? For this practical, guys, so this practical, we need the application to produce the data, right? Say we need the application to produce the data. Okay, we have to create the streaming. Then we have to create the firehose. then we can deploy the data inside S3 bucket. All right. Yeah. First of all, we are going to create the data stream. Okay. This is the data stream component. Let's see how to configure the data stream. Right. Say Kinesis data stream, create data stream. Say data stream name. What is the data stream name? Say demo data stream. Next one, data stream capacity. The capacity measure shard, right? That means shard means write capacity and read capacity. Write capacity means 1 MB byte per second, right? And 1000 records per second, right? If we said 1, it will receive 1000 record per second, right? And it will read 2 MB bytes per second. This is read capacity. This is the write capacity. Say if you change 10, say it is 10 and this is 20. Say 1 is enough. Say write capacity. Say one component is sending the message. It will read those messages in this speed. In this speed, it read the messages and it is going to write in this speed 1 MB byte per second, right? It read, okay. Read this message in this this speed MB byte per second. Then he is going to write this data in the particular stream 1 MB byte per second, right? This is the reading speed and this is the writing speed inside the stream, right? Let's define the read speed and write speed. This is the write speed. This is the read speed, right? Create data stream. Now say we are creating the data stream. Now the data stream has been created. Now we have completed the data stream. Right. Now we are going to create the firehose. Firehose is the one which receive the data from data stream and write it to one of the storage S3 bucket. Now we are going to create this component firehose, right? Say data stream, say delivery stream, say create delivery stream, all right? Wait. Sorry, okay. Go to dashboard and create the firehose. Data stream we have created. We don't have any firehose, right? Create delivery stream, right? Create delivery stream. The source. Say now we are going to create this one. For this one, firehose, this is the source. This is the source, guys, right? This is the destination. it is going to collect the data from data stream. That is the source. Then store the data inside the S3 bucket. That is the destination. This is the source. This is the destination. Right? Right. Say Firehose. The source would be the data stream. Say Amazon Kinesis data stream. Destination would be the bucket, right? Say, let me go to S3 bucket and see, do we have any free buckets? Say, let me choose this bucket, okay? Net experts AWS. Okay, here we are going to deploy the streaming data, right? Say destination S3 bucket and browse, no need to say data stream, just say this is the data stream. The delivery name and the bucket. Here we are going to specify the bucket. This bucket we are going to deploy the data, right? Say this is the source, the data stream. Destination is our bucket. This is the source and the destination. And just mention the name. Just say browse and see if there's any data stream. Just go to demo data stream. All right, and this is the name, the delivery name. You can give any name. Right, there's no lambda here, right? And the destination bucket. This is the destination bucket, guys. And if you have, if there's any folders there, specify the folders. If you would like to encrypt the channel, just go for encryption. All right. Then create delivery stream. Right. Then create delivery stream. Right. Now we have created the delivery stream. Right. Just go to delivery stream. Say dashboard. Now the Firehose is ready. Now the Firehose is ready. Our S3 bucket also ready. Right. Right. So all these components are ready right now. Now we are going to stream the data. Right. Stream the data. So this one, we need to find the application to stream the data. Right. Say, let me find one application to stream the data. Say, let me choose this application, guys. Give me 1 second. Okay, anyway, let's search the application. Let's find the Kinesis data stream. It's in the GitHub, I think. GitHub. Give me 1 second, guys. I found the application to generate the data. say, let me type like this, Amazon classes data. So let's type Amazon classes data generator GitHub. Okay. So this is the application. This one generate the data string, right? This is application generate the data string, right? You can this is the free app. You can get it, right? Just say Kinesis data generator. This is the application, right? Say set. Okay, I already configured a login here, right? Say let me log in using the name, right? AWS admin and the password. I already created a login, right? This is the application, guys, right? It's a free application. You can generate the data, right? You just go to this application and create the login, all right? Say these are the free application. Just go to the documentation, create Cognito user cloud formation. Just create the login, right? Say, let me show you how to create the login. Say here you have to choose these things. Say next, create the login here, right? Give the username and password. I have already created the login, AWS admin and the password. I am going to use this login, right? Say if you want, you can create a new login. Say let me put AWS user and give the password. Say ABC56, right? Login name as AWS user and the password. Say next. Save. Just say next and create the login. Now just say accept it. Create stack. Right. Now we have created the login. It will take some time. It will take some time, right? Create in progress, right? So this is the application, guys. This is the application we are creating. This application is going to generate the data, right? Say rollback complete. Why is that? There's a message. So guys, there's error message here. See, let me create a new one. So I don't want to use my old account. So let me create a new one. Say there's error message here. Couldn't create the account. Right, rollback complete. Just say delete this one. Delete in progress. So let me create a new account, right? Say just choose the this one. Template Amazon S3 URL. All right. Say next. The stack name, the parameter, say username. Let's see. New AWS user, right? Let me mark the user account. New AWS user. Say and the password ABC 1 2 3 4 5 6. Right. Say next. There's a role here. No need to create any role at the moment. Rollback all stack resources. Specify rollback behavior for the stack failure. Okay. If there's any failure, it will roll back. Right. Say stack policy is there. No need to configure any policies. Just say next. Say just user accounts are fine. New AWS user and the password is there. Say acknowledge the AWS. Okay. So last time I didn't acknowledge. That is the reason, right? Create a stack. Now let's see this time. Now, now we have created still in progress, right? Still in progress. Yes, refresh and see. Right, say the output. So create complete. Now we have created the user. Say just go to output. Say let me log in. Say just log in by using this URL. Let me log in. say my username as new AWS, sorry, new AWS user. Say just put the password ABC12345 type new AWS file. Say sign in. Now I am signing in the particular application, guys. Right. This is the Steam generator application. Okay. This is the application is going to generate the Steam, right? Let's choose the region. Say our current region as Virginia, US East 1. Go to the application and generate and choose the region US East 1. Say what is the delivery stream? This is the delivery stream demo data stream we have created. The steaming. Now this application is asking the steaming. That means where do I have to hand over the data, right? The data stream name, right? Constant. Okay. At the same time, create 100 records. Right? This is the message template. You can, if you want, you can modify it or just keep like this. We are sending the data stream. That means at the same time, it will generate 100 records. This application, the producer generate 100 records, right? Right. Say, let me generate the records. Say, now I am going to send the data. From this application, I am going to send the steaming. So data steam is going to receive the steam. Then it hand over the data to Firehose. Firehose is going to deploy the data to S3. Right? Right. All these components are already configured. Right? We just to send the data to data stream. That's all. Right? Right. Let me send the data. Let's see. See the data started, say 100, 200, 300, 400, 500, 600, 700. Now okay, steaming started. Right. So now I'm going to stop this one. Right. Now, right. Now go to this one and see whether, right. This is the this is the S3 bucket. Now see the data stream. Say just click this one. Now see the data stream received the message. See already read some messages. Get record. He received the record. Right. Now, okay, it has been received. Okay. Then it will take some time to hand over the record to Firehose. For Firehose, it takes some time to deploy the data inside S3 bucket, right? Say, just go to Firehose and see. Just go to data stream. Sorry. This is the Firehose, guys. Now let's see. Say record read. Okay, it has been read some record, guys. Say it has been read. Okay, it will bytes data from Kinesis streaming. Now for him, it will take some time to deploy inside S3 bucket, right? Right. It will take some time. Now we just go to S3 bucket and see whether we have received the data from this application, right? Right. Go to S3 bucket. This is the bucket we have chosen. Go to the bucket, guys, right? Go to the particular folder. Say the month is there. Set 28. So this is the data we have received, right? Say just download this one. So now we have received this data. Okay. So we are sending the data stream. This is the message we have configured in the application. Just go to the application. We are sending the data to stream. So now we have received the data and Firehose deploy the data inside S3 bucket. Right. Now it has been deployed. You see the data. It sent, I think, 1024 stream, right? Right. It's collect the data from one of the application and hand over to Firehose. Firehose deploy the data in S3, right? Say if you want to analyze the data, you can use Kinesis analyze the component and analyze the data, right? That is possible. Okay, this is the data stream, guys. This is the Kinesis especially deal with streaming data, right? Streaming data. Now we got the data here. So this is how the Kinesis works, right? Right. Right. Say you can see the components. One is the data stream, other one is Firehose. If you want to analyze the data, you can analyze the data as well, right? So this is about Kinesis, guys, right? Kinesis. Say, right? Right. So if you have any questions, please raise. Or else we move to Lambda. Right. Okay, fine. Let me delete all the streaming data. Right. Just go to data stream and just delete it. Just choose this one and delete. Now data stream is deleting. Just go to Firehose and delete this one. Delete the Firehose as well. Right. Say deleted. Right. Now we have deleted the Firehose and data stream. Right. If you go to dashboard, nothing is there. Right. This is about kinesis, guys. Right. 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 Next one, we head on to a new section known as Lambda. By using Lambda, you can write any programs, say for example, Python, PHP, .NET, anything you can write, right? Say, let's go to Lambda and see. Say, so Lambda. Why is coming like this? So this is the Lambda. Okay, you can create functions, right? Say create function. There are 4 options, guys. Say one is author from scratch, right? That means you can write the program author from scratch. What sort of programs? You can choose the programs here. .NET, Go. This one is from Google, Java, Node.js, Python, blah blah things. You can run these sort of programs, right? Author from scratch. Or else you can use the blueprint. There are some predefined programs. Some are in Python, some are in Node.js, some are in DynamoDB. These are the predefined programs. Okay, right? And the container image, you can call the Docker container image or ECS container image. Or you can create serverless application repositories. Say you can call the serverless program from GitHub. Okay, and deploy it here. Deploy to Amazon. Right. There are 4 options here. Let me choose the first option, author from scratch. Now we are going to write a program. Right. Say guys, this is Lambda. Say this is Lambda is there. Now we are going to write the, say Lambda is there. Now we are going to stop and start the EC2 instances through Lambda by say writing a Python program. We can stop and start this EC2 instances. Say we have to give a special permission to this Lambda. Say what is the permission is, this Lambda should access this EC2 instance. We have to create the role. What is the role here? Lambda access the EC2 instance. This is the role we have to create. This is the role name, or you can give any name, right? Once we create the role, then we are going to write a Python program and hand over to Lambda. This is the Python program. So this is the Python and hand over to Lambda. Lambda will execute the program. Once the Lambda execute the program, we can shut down the EC2 instance. We can start the EC2 instance automatically. Okay. So for example, we need to start some instances midnight for backup purpose. So after 1 hour at 1 a.m., we are going to shut down those instances. We can schedule this Lambda program, right? Right. This is known as serverless concept. Lambda is a serverless concept. Okay. If you want, you can run a program. Say, for example, you are going to run a Python program. This is the Python program. Say, once you run the Python program, Lambda is going to choose the what is the CPU usage for the particular program, right? What is the RAM size? What is the CPU need for this one? CPU, what is the RAM size need for this one? RAM size, what is the storage? The storage those things chosen by Lambda, right? And execute the program. Say, especially some payment card applications, say some .NET frameworks are about to run. On that time, Lambda is going to choose the CPU, RAM size, storage, all the components, all the parameters. That's what this Lambda known as serverless concept. Right? It's a serverless concept. There's no servers here. Just run the program. It will choose the server requirement and run the program. It will customize the bandwidth even. Right? Guys, there's a separate chapter for Lambda, right, in Amazon. So in in Amazon. If you are interested, let me know. Right. Say this is a Lambda. Right. So we are going to create the role here. Right. We are going to create the role. What is the role? Lambda able to access the EC2 instance. That is a role. Right. Let me create the role. Then we write the program and test it. Right. Say, let me create the role first. Say, if you would like to create the role, go to IAM and create the role. Say, go to role, just say create role. Right. Say AWS service, here choose Lambda. Say Lambda should access EC2 instances. Say EC2 Amazon full access. Just say next and create the role and put a role name, right? Lambda access the EC2 instance. Lambda access EC2 instance. This is the role we are going to create. Say create role. Now the role has been created successfully. right? Now go to Lambda, guys. Say just give a function name. Yes, the function name control EC2 instance. Yes, that is a function name. What is the language would you like to choose? Say Python 3.9. Okay, you can choose any languages here. What is the architecture? x86 architecture. And the role name, we just created a role. Use an existing role, guys. Just choose the second option and choose the role. So we have created the role name Lambda access EC2 instance. This is a role we have created, right? Say create function. Now the function has been created, right? Here you can write the coding. Once you write the coding, you have to deploy and you can test it. This is the default function is there. We just take out this Python programming, and we are going to write our own program, Python program here, right? Say what is the objective here? We are going to start or shut down the instances. That is our Python program, right? Right. Let me run one or two instances. Say EC2 launch instance. Say T2 micro. Say let me choose one of these things and say storage. Just mention the name lambda test or something. Just launch one instance. So this is the instance we have created. Now we are going to shut down this instance through Lambda, through writing a Python program and shut down the instance, right? Say this is the Lambda, right? Right. Let me say if you want, you can get some template, right? You can get some template. Say just go to Google and search some template. AWS stop instance. Python, right? Say let's choose this one. Search like this: AWS EC2 start and stop the instance using Python bot 03. You can get some predefined coding. Say This is the sampled example stop EC2 instances, right? So just copy this one, right? Say, just go to the code part, just say remove the previous coding, then say deploy this one. Say this code will stop the EC2 instance. Just see here the EC2 instance, this one is running right now. See, it's running, right? Let me modify this coding, right? Say import, we are importing one module, and say region. This is our region Virginia, so this one is the region. Copy and paste the region, just copy here and paste it over here. So region, and the instance ID, you have to put instance ID. Just go to the instance. This is the instance we have chosen. Just copy the instance ID here. Just paste it here. This is the instance ID. EC2, there's okay, EC2. So say we are going to choose stop instance. Now if we run this one, the instance is going to stop. The message like stop your instances. Okay, it will throw the message, stop your instances. It will print the message, stop your instance, and it will get the instance name. So the instance name, right? Now the Lambda program is ready, right? Now we are going to deploy this coding. Okay, deploy. Once we write the program in Lambda, we are going to deploy the code, right? So click here to deploy the code. Now we have deployed, right? Right. Let's see. Say this is the configuration. There are some configuration parameters. What is the memory size we are going to allocate? If you want, you can change the memory size, right? Say what is the timeout period? Just put 10 seconds. It's a timeout period. We are using existing role, the role name as Lambda access EC2 instance. Save these things. You can configure the amount of RAM, you can amount of CPU, right? Those things you can configure here, right? Aliases, versions, you can define the version for this program. You can see the coding. This is the coding we already deployed. Say changes deployed, right? You see the instance. Right now the instance is running state, right? Now we are going to execute the program. If we execute, this instance is going to shut down, right? It's going to shut down. Say go to the program, then say test. Okay, we are going to execute the program right now. Test, just say test, and just give the event name, my first Lambda, right? Just give the event name, then say create. Now see, now the program is executed, right? Say wait, say run again, say, right, now it's running. Now say the response, now the program has been executed, right? Right. Say now go and see the instance, just say refresh and see what is the current status of the instance. Say you see the stopping, the instance is stopping. Okay. This time a lambda stop the instance, the coding stop the instance. Here there is no human interaction. Just these things we executed through lambda. A lambda stop the instance, guys. Say just refresh and see the status stop. Now the instance has been stopped here, guys. Say go to this one execution. This is the execution result and the duration milliseconds and the memory size 128 MB memory has been used. Sorry, this is the memory size. Use memory is 75 MB. 75 MB has been used to execute this program, right? And the duration, blah blah things, right? This is the response, right? Now the instance has been stopped, guys. If you would like to start the instance, you can go to the program and say remove stop and say start. Just say start the instance. First of all, you have to deploy the coding. Just say deploy. Now the code has been deployed. The new code has been deployed, guys. Say test. Now it's throwing some errors. Say response error. Error messages are there. EC2 object has no attribute, STA. Wait. Attribute type. So guys, let me EC2 STA start instances. Say let me put start. Again same message. Say EC2 object has no attribute, STA instances. So let me. So let me go with this start instance. Say this is the start instance coding. So let me go with this one. So the both are same. There's no EC2 dot to EC2 dot. Say let me copy and paste this one. Maybe this may be the issue. Just remove this line. Yeah, okay, just paste it this line. Maybe that may be the reason. Let's see. Right. Say deploy this one. Other parameters are fine. Just say test this one. Okay, this time it works fine. Okay, works fine. Now see the instance. Just say refresh and see whether now say started. The instance has been started. Right. So through Lambda, we can control the instances, stop the instance, start the instance, reboot the instance. We can get the backup from the instance. We can do anything, right? Right now, it says still is running. Right? Maybe the issue is my coding. Maybe the EC2 is the issue. Maybe some letters missing or something here. Right. So this is the way we can stop the instance. We can start the instance through Lambda. We can write Lambda programs. Okay. Inside Lambda, we can run Node.js, Python, PHP, anything as you wish. .NET, Java, right? This is about Lambda, guys. So if you have any question, guys, please raise. All right. So far, no question, guys. Then we will get a short break. Now the time is 3:15. We will go up to, we'll start at 3:30. Right? We'll get 15 minutes break. Okay, then we'll get short break. Well, guys, let's start. So we have completed the Lambda, right? So here just write the program first, then deploy, then you can test it, right? Meantime, you can define the resources. Say go to configuration. Here, just define the resources. Say the RAM size, the timeout period, those things. Meantime, you can monitor your codes, right? If you enable CloudWatch, you can monitor your codes, say invocation, duration, blah, blah things, right? The test is there, right? Just give the event name. Every Lambda program, you have to give an event name, right? Just give the event name and just test it, right? And this is the code part, right? You can write any coding as you wish, right? This is the Python program, right? Py, say Py is Python program, right? Likewise, you can run any sort of programs as you wish. Right. This is about Lambda, guys. Right. Okay. Right. Right. Next, we head on to another service. There's a totally new service known as container service. Right. Container service. Like we can run the Docker Kubernetes. Likewise, we can we can execute Amazon container service, the service known as ECS, right? Elastic Container Service. Right? Say, just go to the slides and just see these things. So I already uploaded a Docker presentation and recording, guys. So please go through, then you get more idea about ECS. Right? So I assume you all know the Docker, right? So if you know Docker, this one you can easily understand, right? Say one is Docker. Let's see about Kubernetes. You can run Kubernetes in Amazon, right? To control the container. Right? Okay. If you want to control, if you want to control the container, you can control through Kubernetes, or else you can use ECS. Okay, Elastic Cloud, Elastic Container Service. Right? There are two possibilities. Right? You can choose as you wish. Right? Here we are going to study the ECS, right? Elastic Container Service, right? Say, let me touch something about Kubernetes. Say what? Okay, let's see what is Kubernetes, right? Say like something like this. Say guys, this is the computer, EC2 instances, right? Say you can get the images, you can get the application images, you can get the OS images, okay, from Docker Hub, right? Say let me touch something about Docker, guys, then that would be ideal for this chapter. Say you can create a free account in Docker Hub. There you can download the Docker images. Say hub.docker.com. I already created an account and just log in. Here you can find the images, right? Operating system images, application images, database images. Likewise, you can find the images. These are the free images. These are the Docker images, guys. Nginx, Python, say BusyBox, MariaDB. Okay, these are the free images. You can use it. Right? So this practical, we are going to use this image, say Nginx image. We get the Nginx image and deploy to our ECS containers. Then you may ask the question, how to control the containers? You can use Kubernetes to control the containers, or else you can use ECS to control the containers. Kubernetes, guys, is a separate chapter, right? Here we are not going to discuss Docker or Kubernetes, but we are going to do the practical on ECS. This is the Amazon built-in service, Elastic Container Service, right? Kubernetes is the one manage the container. Kubernetes is the one manage the Docker containers. Say guys, this is the physical machine. Say guys, this is a physical machine, guys. Right? You can download the images from Docker Hub and create the container and run the images. This is the container. You deploy this one inside the container and run the images. You can create any amount of containers. Docker containers. This physical machine known as Docker host. Docker host. This is the Docker containers. Sorry, containers, right? Docker containers. Okay. Here you can deploy the images and run the containers. If you want to manage these containers, you can use Kubernetes. Kubernetes or ECS. Amazon we use ECS. There's another software known as Kubernetes also. You can manage these containers, right? Let's see something about Kubernetes first. Says K8 SQB is open source container orchestration. Orchestration means manage the container, right? Or orchestration platform that automates many of the manual processes involved in deploying, managing, and scaling container application. Managing and scaling, deploying the containers. Kubernetes was originally developed and designed by Google. In other words, you can cluster together a group of hosts running in Linux container, and Kubernetes helps you easily and efficiently manage those clusters. All right. Kubernetes clusters can span hosts across on-premises, public, private, hybrid cloud. Use cases. Orchestrate containers across multiple hosts. Make better use of hardware, maximize resources need to run your enterprise application. Control and automate application deployment and updates. Mount and add storage, blah, blah things. Scale containerize application and other resources on the fly. Health check and self-heal your application with auto placement, auto restart, auto replication, and auto scaling. Right? So we can do these functions by using Kubernetes. Right? Right? Say for example, guys, say there are two Docker hosts are running here. Docker hosts are running. Okay. By using this Docker host, you can create one container. Right? And you can run the particular application. Right? Say if this one fails, how to manage the container? If this one fails, how to manage the container? Those things we can manage by Kubernetes. Right? Say here, this is the container instance. This is the ECS cluster. This is the container instance. We can run the task. Right? Right. Let's see how to configure this setup. Right? So, before that, let's go to this one. monolithic application and microservices. Say, let's see what is monolithic application. What is microservices? Okay, let's see. This is the cut-to-cut comparison between monolithic and microservices. Say, monolithic means monolithic is built as one large system and is usually one code base. So the whole system is running in one large system, right? Say code base means, say you can run the particular application in one code. Say if you use Java, all your codes would be Java. Say if you use .NET, the whole code should be .NET. You can't change the coding. But microservices, we can change the language. Say this is the wait. Say this is the one of the microservice application, right? Say for example, say payment gateway application. Say the card application you can run in Java. The card application to test the card, okay, to connect with the bank, okay, those things you can run with Java. And processing the card details, you can run with .NET. Get the particular card interface, you can run with PHP. Right? To collect the customer's payment, you can run with Node.js. Here, all these applications are separated and they do separate functions. These are loosely coupled. Say microservices, all these applications are loosely coupled. But monolithic, say you can use different application, right? You have to go for Java or .NET or some sort of program. Here, you can use different languages and you can create a small set of programs, right? Right. This is then you can separate the database even. This is a customer database. This is the payment database, right? Likewise, you can separate the databases as well, right? Microservices, right? Okay. So it is not easy to scale based on demand. Say microservices application, each project and service are independent from each other at code level. Therefore, it is easy to configure and deploy completely and also easy to scale based on demand. Okay. You can scale the application. Okay. All the components are independent. Right. Here, monolithic. Say if you change one component, you have to change the coding in other related coding as well, right? It has shared database. Say shared database. Say here each project and module has their own database. Each project and module, they have their own database and the application. Here, you have only one shared database, right? Large code base make IDE slow and the build time get increased. So the build time get increased since you have bulk of coding, right? Each project independent and small size. So overall build and development time gets decreased, right? Tightly coupled, guys, see, tightly coupled. Here, loosely coupled. All the components are loosely coupled, but here all are tightly coupled. Say, anything goes wrong in one coding, you have to change all other related codes, right? Say that is known as monolithic application and microservices, right? So the ECS or Docker or Kubernetes well connected with microservices, right? Each Docker host, each Docker container, you can run separate application, right? Say this is the Docker host. Each containers, you can run separate application. This one you can run web server. This one you can run app server. This one you can run a database. This one you can run your backend program, blah blah thing. Okay. Likewise, you can separately run your programs in Dockers, right, or containers, right? Right. This is about monolithic and microservices, guys, right? Right. Now let's see the ECS now. So let me type ECS, Elastic Container Service, guys. This is the service we are going to configure right now. Let me delete the Lambda node. This is the service, guys. Say something like this. Say when you open this one, let me refresh. Right now, I already configured this ECS, guys. Right, I already configured. Anyway, we are going to configure again. Now see, I already configured. Just go to the instance. Say go to the instance. Let me access this instance, right? Say let me. So this instances created by ECS, not me, right? These instances ECS created by this one and this one, created by ECS. Right? When we sorry guys. So when we start the ECS created the instances, right? And configured the auto scaling group. Now see, go to auto scaling group. There's a auto scaling group, guys. You click here. Say you can see desired capacity or right now minimum capacity, maximum capacity. Okay. So these things configured by ECS. And the target group, sorry guys, there's no target group right now. Okay. There's no target group, but it's configured the auto scaling group automatically. Right. Now let's access these instances. Just go to the instance, guys. Let's access this instance, right? Say, let me copy and paste here. This is HTTP. Now you see here, Nginx is running. We got the image from the Docker, this one. We pull the image and deploy to ECS. That's what we can see these things. The Nginx, right? Right. So now see, right now we have 2 instances are running. I am going to create new ECS. Okay, so that new ECS is going to deploy some instances, right? Let's see how it works, right? And meantime, ECS is going to create the auto scaling group. Okay, that means anything goes wrong in this instance, auto scaling group is going to create the new instance and help to ECS to run the tasks perfectly, right? Right. Let's create the new ECS, right? Right. Okay. There are 2 consoles here. One is old console. This one is new console. You can choose anything, old console or new console. The thing is, guys, new console has some bugs. That's what people prefer old console, right? Say, let me choose old console. Just off it, just say skip it. This is the old console, right? Right. Say, first of all, let me create 2 instances, right? Right. Say, go to the cluster and create the new cluster, right? Let's say ECS. There's a one cluster is running. C10 is a cluster, right? EC2, right? Right. Before that, we will see one presentation and again come back and create. Right. Now see. Amazon Elastic Container Service is a highly scalable, fast container management service that makes easy to run, stop, and manage container on the cluster. Right? Say, this is the EC2 instance, guys. This is the computer. Inside computer, we are running the container. Inside container, we are running the task. Task 1, task 2 is one container. task 3, 4, 5, 6 in another container. Right? We are running the task inside the container. Right? The containers are running inside the EC2 machine. Right? EC2 machine. Right? Right. This is okay. This is one setup. If not, you can go for AWS Fargate as well. Here is a serverless concept. There is no container. Sorry, there is no host. There is no EC2 instance. Here we are running the task. Once we execute the task, there's a container automatically created and run the task. Okay. If we run task 2, a container automatically created and run the task. Okay. That is known as Fargate. The main difference between this Fargate and this one is this containers are running inside the EC2. Okay, but here this one is running, just running. There's no EC2 instances. There's no EC2 host. Right? That is the difference between AWS Fargate and this one, the container T6. Right? Right. Let's see what are the difference here. So you guys give me 1 second. Right. Say deploy and manage your own cluster of EC2 instances for running the containers, right? Right. You deploy the containers inside EC2 instances, EC2 machine, right? With EC2 launch type, billing is based on the cost of the underlying EC2 instances. Say here the cost is based on the instances. Say if you choose 2 computers, then cost for the computers, not containers, right? So this allows you to optimize price by taking advantage of billing model, blah blah things, right? If your workload has consistent demand on many CPU cores and many gigabytes of memory, you want to optimize your price, you should consider running cluster of reserve EC2 instances or spot instances. You can go for reserve EC2 instances or spot instances. If you go for testing purpose, choose spot instances, guys. We have discussed. Okay, say if you want to run the particular containers for some time, then you go for reserve instances, right? It's up to your application requirement. You will be responsible for managing this cluster. That means we are going to manage the cluster manually, right? So then your next question would be, how would you manage the container? We just install Kubernetes, then we manage the containers, right? On the other hand, let's see about Fargate, right? Here we just run the container. Inside container, we just run the task, right? Say here, run container directly without any EC2 instances. Just run container without any EC2 instances, right? With AWS Fargate, launch tight billing based on how many CPU cores and gigabyte of memory your task requires. Say, if your task requires more CPU and memory, the charge for the task, right, per second. You only ever pay for what your task uses. Or no more pay for EC2 capacity that goes unused, right? Here you just pay for the task usage only, right? Forget. Right. Say, managing large cluster of EC2 instances can be somewhat hard. That means the somewhat hard means you have to install the Kubernetes and okay, do those kind of things. So here we have to manage these things. Here Amazon is going to manage the containers. Right? Here we install Kubernetes and manage this container. Here the responsible goes to Amazon. Right? Say the patch management and blah blah things update, those things is managed by Amazon. Right. This is ECS cluster. You can use this is a Fargate. Just run the containers and just execute the tasks. The billing for the tasks, the how many tasks you run, right? So let's okay. This is about Fargate, and this is about EC2 instances. So in this practical, we are going to use EC2 instances, not Fargate, guys, right? Say let's see how to configure this one. Say meantime, this is the cluster. Say first of all, we are going to create the cluster, right? Say let's see what is cluster. Amazon ECS cluster is a logical group of tasks or services. You can register one or more Amazon EC2 instances, also referred to as container instances, right? With your cluster, you run tasks on or you can use the serverless infrastructure that is Fargate. Okay, you can use EC2 instances or Fargate. When your tasks are running on Fargate, your cluster requests are managed by Fargate, right? Right. Let's configure cluster, right? Number one. Just go here and just say create cluster. Say this one is Fargate. This one is EC2 instances. This one is Windows. Okay. This one is Linux. Say if you would like to configure Linux instances, go for this option. If you would like to configure Windows EC2, go for this option. If you go for Fargate, go for this option, right? So let me choose this one. In this practical, we are going to use EC2 Linux, not Windows. EC2, just say next and say what is the cluster name, right? So we are going to give the cluster name, guys, right? We are going to give the cluster name. Say cluster name as say cluster 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 12 or something, right? Just give any name. This is the okay. on-demand instances. We are going to deploy on-demand instances. If you want, you can deploy spot instances as well, right? On-demand instances. And what is the hardware we are going to choose here? Just say T2 micro. Since T2 micro is free, so better go with T2 micro. T2 micro, right? So how many instances would you like to run, right? Say how many instances. So we are going to run 2 instances, 2 computers, 2 computers. Say let me choose 2 computers. What is the AMI? I choose AMI and the size of the hard drive, right? Each 30 GB bytes. What is the key pair would you like to choose? Say, let me choose demo key. Say, let me see demo key is there, right? Yeah, is there, right? Say, then where would you like to deploy this EC2 containers, right? Say, let me choose the VPC. Let me choose the default one. If you want, you can create new VPC and deploy your EC2, right? Sorry, ECS, right? Say, let me choose the default one. The subnet is asking, say, we are going to run 2 EC2 instances. So then better to choose 2 subnets, right? This is subnet, guys. Subnet 1. This is subnet 2, right? Right. This is the container host, the host machine. Say, let me mark. This is the container host, CH. Container host, right? Let me choose 2 subnets here. Say A, whatever you want, right? Say A and B. Easy to remember, A and B, right? Say one instance goes to A, other instance goes to B, right? Say auto assign public IP address. Would you like to access these instances from outside? Yes. We would like to access this one from outside. Then say enable public IP address. Say assign public IP address. Then configure the security group for the instance. Say, let me go with for demo SG as you wish. And the container instance role, just go with this role. All right. Just say create. Now we are creating this, right? ECS. It will take some time. Now we are configuring the cluster. Okay. The cluster name as CL12. Right. Okay. Right now is creating. Right. Let me go to the slide. The cluster we have created. Container instance. This is just EC2 instance that is part of ECS cluster and has Docker and the ECS agent running on, right? Say we are say inside the EC2 instance, we are going to run the containers. Okay, we are going to run the containers. Inside containers, we are executing the task. What is the task, right? Right. Container agent is there. Then we are going to define the task definition, right? To prepare your application to run in Amazon ECS, you create the task definition. Say if you would like to run Apache inside the container, first of all, you have to create the task, right? The task definition in text format, JSON format, describe one or more containers up to maximum of 10, right? task definition specify various parameters, application, blah, blah things. Okay. Then now we are going to create the task definition, right? Right. Say, let's see the cluster. Now the cluster part is okay. We have created the cluster, right? Right. Say view cluster. Say now we are running two instances. Instances, guys. See now go to EC2 instance and see. Say let's see we are running other two instances. Belongs to CL12 clusters. Okay, CL12 clusters. Right. The cluster name is CL12. Right. Say guys, now see the cluster name. This is the cluster name. Huh? What is the cluster name here? CL12. Say now see all are virtual things. Huh? Just say this is the cluster. Inside cluster we are running the EC2 instances. Right? Here we are running the containers. Right? Now meantime go to auto scaling group and see here this is the auto scaling group. Okay, it's also about to run, right? Say anything goes wrong in one instance, auto scaling group automatically create the instance, okay, and put it to this cluster, right? That's what we need the auto scaling group here, right? Who has created these instances and auto scaling group? ECS created the instances as well as the auto scaling group, right? Say, let's see how many instances inside. There are two instances. Desired 2 right now is 2, minimum 0, maximum 2. Right? Right. Right. So we are running these two instances, CL12. Right? Here you can see, now we are going to define the tasks. Okay, this is the task definition, not tasks. First of all, we are going to define the tasks. Then we are going to run the tasks. Definition is different, running is different. Say now click task definition and define the task here. Say create new task. Say I don't want all these things. Say anyway, just create new task. Now is asking where would you like to deploy? Fargate. Again is asking Fargate or EC2 instances or external. External mean we can use Kubernetes to run the particular containers. That also possible. Right? Say let me choose EC2 instances. Right? Say that is the what is the task name? Say let's see demo task. Say okay, this is the task name. EC2 instances we use we deploy this one in EC2 instances. Right? Say role part just leave it, right? Say network mode. Say what about this container network mode? Right? What is the mode? Say if you click here, bridge mode or host mode or none. Okay, better to choose bridge, right? So these things I already discussed in the Docker. Please refer my Docker recording, right? Just choose bridge mode, right? Say bridge mode is like this. Say, anyway, I just go through the bridge mode. Say, this is the computer, the host, the real machine, bare metal hardware. Here you just install the VM or something. Inside VM, you deploy the VMs. This is VM1, this is VM2, this is VM3. Likewise, you deploy the VMs and choose the bridge mode. And this bare metal hardware is connected to your 4G router. If you choose bridge mode, all these components, that means your bare metal, your VMs, are in the same network ID. Say, let's see, 192.168.10.0/24. That means this one would be 192.168.10.1. This one 192.168.10.2, 10.3, 10.4. All your machines are in the same network if you choose bridge mode, right? Better to go for bridge mode. Say task execution role capacities. Then you can define the RAM size and the CPU size. Is especially for Fargate. If you go for Fargate, you have to define the resource allocation. Say this is 500 MP for this one, and CPU, just put 2 CPU or something, right? Likewise, you can configure it, but just wait. Just leave it this one, right? So what I can do is, now I can go back. Let me go back. Just go to previous and come back. Just go to EC2. Wait. Say go back. I create new task. EC2. Just give the task name. Demo task. The role no name, just use the bridge mode. And no. Okay, this is for Fargate. Right? Don't configure any parameters here. Right? Then the container. Right? Now we are going to configure the container. Right? The container. Right? Container. Say container. Inside container, guys, we are going to run the image. We get the image from Docker Hub and deploy to container and run it, right? Say at container, the container name, say C12. The image you get it from Docker Hub. Okay, say let me run nginx this is the web server. What is the memory you allocate for the container? Say soft limit, hard limit. If you define hard limit, then your container go beyond a particular amount of RAM size. If you define soft limit, then it go beyond the particular limit. Okay? That is a difference between hard limit and soft limit. Say, let me choose the soft limit and just say 256 is enough. Right? And the port, what is the port would you like to map? Port 80, 80. The host port 80 and the container port is 80. Say guys, say this is the container port is 80, right? The host port also 80, right? Say whatever traffic comes here is hitting port 80, the host it point to the container, right? Port 80, right? This is the host port, this is the container port. You see here the host port, container port, the TCP protocol, right? Keep as it is. Right. Other parameters, the health check and all, just leave it, right? At. Right. Now we have at one container, guys, right? So, right? Okay. That is enough. Then say create the ASICs, create the task definition. Now we have successfully created the task definition, right? Now we are going to configure the task, right? Say go to the cluster. This is the cluster we have created, EC2 cluster. Say go to the cluster and say configure the task. Say run new task. Say EC2, the task we are going to run inside EC2, and the task definition demo task is the task definition, is the revision number, and the cluster, this is the inside this cluster we are going to run the task. What is the maximum number of tasks you can run? Any amount, just say 2 tasks, right? And say you are going to run the task inside the containers, guys. Say just say run task, right? You can see now the task started. Task started. What is the task we have given? To run the Nginx server. Okay? Run the Nginx server. That is the task. We are running 2 tasks, right? Still is pending. It will take some time to run the task. Just say refresh and see whether it's running or not. Just say refresh and see whether right. Now see the tasks are running. Now see the tasks are running. Now, how do we confirm this one? How do we confirm? Right. Go to the instances. This is the CL12. Just go to the CL12 and copy the IP address and see whether this thing is running or not. Just paste it. HTTP. Enter. Now see, we are running the Nginx web server. Let me go to other instance and see this one and see whether it's running or not. Just put HTTP. Say enter and see. So okay, we are running the task, right? So say this is both tasks are running, right? So both tasks are running. Here we are using port 80. Say we are using port 80, right? Right. So guys, this is about Elastic Container Service, right? Elastic Container Service, right? So if you have any questions, say this. Say sometimes this topic might bit hard for you, right? I know, right? Right. What you can do is just go through the recording and just create one ECS, right? This is about ECS, guys, right? Right. So if you have any questions, please raise. Next one, we move to another topic, the final topic, right? That is known as database migration, right? Anyway, this one is not in the syllabus. Anyway, we will discuss this as well. How we are going to migrate the databases, right? One location to another location, or one database to another database. Okay, that is our next topic, guys. Right. Meantime, we are going to remove these components. Say just remove the task definition. Say just click here. Deregister and just remove the task these things. And say remove the clusters. Delete cluster. Delete me. It will take some time, and I will remove the cluster as well as it is going to remove this EC2 instances as well. All right. Now, this is about ECS, guys. Next one, we will see the database migration part. So go to the database. This is the RDS part. This is the okay. First of all, we will create two databases, right? Right, two MySQL databases. Then we add some database and tables. Then we migrate this data in this database, right? Say both are MySQL databases. Right? So you can migrate MySQL to Oracle, okay? Or you can migrate your premises database to Amazon, okay? Whatever, right? Say here, let me choose two MySQL databases. Let me create two MySQL databases. Say create database. Say, let me choose MySQL. Say, let me choose free option, the database one, and the username and password, master username and password. Let me put ABC12345 ABC12345 right? Say T2 micro is enough, okay? And the storage capacities, enable storage auto scaling, connectivity. This is the VPC and all, subnet and all. We need public access, choose public access. This is the default VPC, default one. And VPC security group, and just say demo SQ or something. The subnet would be this one. So the not subnet, availability zone would be this one. The password and blah blah things, say create database. At meantime, create another database as well. Still is creating, guys. Say create another database. Say, wait, where is MySQL? Oh, we have to wait, guys. Okay. Okay, we have to wait. Let it create this one. Okay. MySQL is there, MySQL. Then this time I'm going to choose the free one. Database 2. The admin is a username. And the password is ABC12345 ABC12345 right? And the T2 micro, this one. This I need public access. Right. Say let's go for a demo SG security group. You can choose any availability zone. Let me choose B this time. Right. Say create database. Now we have two databases. One is this database one. Other one is database 2. Right. Still we are creating the databases. It will take some time. It will take few seconds to complete. Wait. Meantime, let me run the Linux machine to connect. So let me run Linux machine here. Right, so let me check my databases are ready. Say still is creating. Let's say refer still is creating. Say one database is ready. Now, then we are going to work with the database. Just connect this database from outside. Okay. Connected. Let me add some tables here in this database. So now we have create one database and create some tables and add some records here. Meantime, let's see other database. So let's see, just refresh and see. Yeah, it will take some time anyway. Anyway, meantime, we go with DMS, database migration service. Database migration service. Create replication instance. Right. Here you have to create the replication instance. That means it's like this. Say this one is your source database. This one is your destination database. Someone in the middle take this data and deploy it here. Right? This is the database one. This is the database 2. We are going to create one instance. This instance, we are going to define what is our source database and what is the target database. Right? Let me create this instance first. Instance name db replicate for db migration or something. Amazon resource name is not must. Description. Just say what is the instance type? T2 micro. This is the engine details. Let me choose say let me choose okay, let me choose this is okay. Right. What is the hard drive size? The VPC, the default VPC. Would you like to go for multi or single? Just go for the single asset. Public accessible. That means we can able to access this instance. Just go for advanced. Say availability is on and blah blah things is asking. Default, okay, availability is on. Let me put this one. A VPC group, security group. Say demo ST. The keys and all. Okay, it's not must guys. Just say. It's also not must. Just say create the instance. Now we are creating the replication instance, right? Meantime, see our database is ready, right? Both are ready now, right? Both are ready now, right? Our data are here, okay? Database one, right? Now we are creating the migration instance. This one we are creating migration instance. Phil is creating this. Now the instance is ready. Instance is ready now. Now we are going to migrate the database. Just click here. All right. Say endpoints. Is the endpoint say create database migration task. Task identifier db migrate, right? And choose the instance. We have to choose this instance, source database and target database. We have to mention that source is database 1, target is database this one, database 2. Say source is database 1, target is database 2, right? Say migration type, what is a migration type would be? Migrate existing data and replicate ongoing changes. Migrate data changes only. Say migrate existing data and replicate ongoing changes, right? Right. Existing mode, the wizard mode, disable custom CDP, okay. Drop tables in the target, don't stop. All right. So let's just leave other parameters as it is. Okay. Then say create task. Mapping rules. say add roles. Say just add some rules here, right? Yes. Wait, give me a second. At least one selection of rule is required. Wait. Let me put the existing data and migrate existing data. Okay. Just go for migrate existing data. That's all. Migrate existing data. Selection rule. Yeah, we have to add a rule. Say schema. Say schema name is database one, right? Now the migration process started. Right? Now the migration process started. Now all the data here deployed here, right? So migrate, DB migrate creates successfully. Now we have migrated. Now they is saying ready. Now we have migrate all the data here, right? Say the status is ready, right? Now we have migrated all our data here, database 2. Say let me connect database 2 and see whether we can see the same data here. Go to the database 2 and say use this one and connect. Go to this one. Say get another new console. Say MySQL -q admin -h, paste it, -p. Sorry guys, command, there's a wrong is the command. MySQL, MySQL these things. ABC 1, 2, 3, 4, 5, 6. Now connected, just say show databases. Let's type So we see AWS here. Right. So wait, database is not here. Wait. Let me. I think something wrong somewhere because we don't find any databases, guys. Say, let me create new task and say, let me create. Yes, delete this PMS. So we don't find any databases. So let me delete this one. Say create task. DB duplicate. The database name is AWS. Let me just enable migration. Just say create task. Let me create new task, but I couldn't see any databases. Say I should actually this database AWS is here. The database won't be here. That's what I just confused. Anyway, I just see it this time. This is the way we migrate the databases, guys, right? Now it's ready, right? Let's see now the databases are there. Databases. No, there's no databases, guys. Something wrong. So, guys, what I can do is I just only this part database migration. I just separately record it and I will upload. So databases. So AWS is there, but if you see here, it's not there, but it's saying migrated. Database migration has completed, right? But let's see this one. It's ready full load. Anyway, guys, so the database is not migrated, but it's saying migrated, but it's not migrated. So what I can do is I'll check my site. So what I can do is I just recorded these things in another video and I upload it in the group. Right? So this is the final part, guys. Right? So now we have completed all the chapters. Right. So anyway, I'll share the question paper again. There are some updates in the question. I'll share the question paper again. Say meantime, please go for the practice test, right? So now we have covered all the chapters. Please do the practice test, and I'll upload some question and answer recording, right? And next class we will go for some more questions if you want, right? So I'll upload some questions and answer tomorrow, right? I think that's enough for you, right? And meantime, do the questions which are in our site, right? Net Experts site, right? Say, meantime, guys, we are going to start a couple of courses like DevOps and all. If you are interested, let me know. So we'll start. Right. So guys, any questions from your side? And you can take the exam at home as well. Okay. Guys, you hope you all can pass. Still, there's no failures. All got pass. And meantime, before you take the exam, just at least 1 or 2 days before, just ping me and confirm the updates, questions updates, right? So guys, any questions from your side? So guys, any questions from your side? You will get recorded questions and answer on Tuesday. Okay. So that would be helpful for your exams. Right. So guys, then we'll wind up the class. Hope you all pass the exams. Okay, thanks for participating, guys. Right. Thank you. Good luck.
Thank you, sir.